So in this video here, we're going to take a look at how we solve a system of equations by graphing. Before we get to that, first I just want to define what I mean by a system of equations and what does it mean to actually solve that. So a system of equations is when we can look at two or more lines at the same time. What that means is that when we're graphing, we're going to graph actually two lines at the exact same time. Officially, a system means two or more, but for our case, we're going to look at two lines at the same time. And then to solve this means that we are trying to find, so to solve a system of linear system means to find the point of intersection. And for short form, we'll often refer to that as the POI, the point of intersection. So a system of equations is two lines at the same time, and to solve that system means that we want to try to find where these two lines cross or what their point of intersection is. And we get towards the end of the unit, we'll see why that is important. There's many situations that we can look at where we can use two equations to model the same situation. And what we're looking at is what is the one point that is on this line and is also on this line at the same time. In other words, where is our point of intersection? A little bit with some formality as we start looking at this. If I ask you to solve, and here is our system, we have two lines. For good form, I do expect that beside the lines you will number them. Normally when we number them, we put the numbers in circles just so that this looks different than any of the numbers or terms that we write in the equation. And then if we talk about either of those lines, we can then just use those numbers here and say, well, for equation 1, what I know is that the slope is equal to 1 and that the y-intercept is also equal to 1. And for line 2, I know that the slope is equal to negative 1/3 and that the y-intercept is negative 3. So our first step, much like what we were reviewing in our last lesson, is just to go ahead and graph these two lines. And as you can see, I've already set these up to graph them using the slope and the y-intercept instead of making a table of values. We can graph these whichever way you want. It's just that this here tends to be our most efficient and fastest way to do this. And if we have to graph two equations in one question, we want to try to graph them as efficiently as we can. So for our first line, we have a y-intercept that is at 1, and we have a slope that is also 1. Remember from our last note, I can make that a fraction. So we're going to rise 1 and run 1. Rise 1, run 1. There's our next point. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1, and so on and so on. Since we are trying to find a point of intersection, typically what we will do is we will very quickly use our slope to graph basically as many points as we can so that we can get a very accurate line being graphed. If I'm going to try and figure out where these two lines cross, I want to make sure that I've graphed it very, very accurately. I can also now use this number to label my line. In other words, that this now is our equation 1 without having to write the whole equation out. Similarly, for our second line, we have a y-intercept at negative 3. Reminder as we're doing this that to make sure you do plot your y-intercept on the y-axis. One mistake that I see students commonly make is they end up putting the y-intercept on the x-axis and then their line is not graphed correctly. Our slope, we're going to rise negative 1, run positive 3. So I can copy that point out a couple of times. Clearly we can see as we draw this that we're going to intersect back here. So I'm going to use this pattern backwards as well to find that, hey, there is our point of intersection. I'm going to keep going one more time. Okay, so we can finish graphing this line. There it is. So there is line 2. And then we can very quickly see, well, there is our point of intersection. So our conclusion then to this question is then, therefore, the POI, the point of intersection is, and just be careful as you're reading your coordinates that we are doing x coordinate first. so negative 3, y coordinate second, so negative 2. There is our solution, or our answer to this question. Informally, we can always check if this is right or wrong. If we wanted to do a check, we can actually just take this point of intersection and we can double check, does it work on this line? In other words, for equation 1, if I look at the left side and the right side of that equation, I can say the left side is y and the right side is x plus 1. So if I take my answer, the left side is negative 2, pardon me, our y value. Our right side is x, negative 3 plus 1, which is also then negative 2. So we can see that when I sub this point in, that point does work on that line. And we can also check then on the second line to see if it works with that line as well. In that second line, left side, right side, our left side is y, our right side is negative 1/3 x minus 3. Means that our left side is negative 2, our right side is negative 1/3 times negative 3 minus 3. And if we complete this, negative 1/3 times negative 3, that will give us positive 1. So 1 minus 3 is negative 2. So we see that that works there as well. I've formally written this out just so you could see how we can check this, but you can just do what I've done here formally, sort of just as a mental check. If you want to see, do I have the right answer, you can just take this ordered pair and you can sub them into the equation and just double check, am I getting a point that works for both of the equations? And we can see that when I wrote this out, this point does work for both of those. In our second question here, I'm only going to do 2 with you today. We have a little bit of work. And that work really comes from our last lesson, and that is, if I look at that first equation, what am I going to do to be able to graph that? So if I want to graph that second equation, then I'm going to have to rearrange it to its slope y-intercept form, as we saw in our last note. So I'm going to say, well, with that equation, so 4x plus 2y is 12. Again, we're trying to isolate the y. So I'm going to get rid of this term. So opposite operations, I'm going to subtract that term off. So I'm going to get 12 minus 4x. I'm going to divide each term by 2. So if I do that, I get y equals 6 minus 2x. You can leave it like that. Just got to be careful that our slope is with the x, our y-intercept is the other number, or I know some students will prefer to rewrite this in y equals mx plus b form, so I'll just flip those terms around and there it is. And then we can clearly see here that our slope for this line is negative 2, and our y-intercept here is 6. Similarly then for our second line, okay, we can say 2x minus y equals negative 2. As I isolate for the y, I'm going to have negative y. Watch that we don't lose that negative. To get rid of the 2x, I am subtracting that off. I'll be really careful. Sometimes students stop here. This is not isolated. Again, we got to remember that that is a coefficient of negative 1. So I do need to go through each term here and divide everything by negative 1. And as we do that, then now we will have y by itself. We have negative 2 divided by negative 1 becomes positive 2. Negative 2 divided by negative 1 becomes positive 2x. And then again, if you prefer, we can rewrite that in this way. So here we have a slope of 2 and a y-intercept that is also 2. Graphing our first line, we have a y-intercept at 6, so almost off the graph. We have a slope of negative 2, remember that's over 1, so rise negative 2, run 1. We'll copy that pattern until it doesn't fit anymore. Connect our dots to draw our straight line. And I'm going to label it. There is our equation 1. Our second equation, we have a y-intercept that is at 2. And we are going to rise 2, run 1, rise 2, run 1. We can see our point of intersection right away. I'm going to plot a few extra points just so I can draw this a little bit more accurately. In this case, I don't necessarily have to go all the way to the end. So there is our second line. And then our conclusion. Okay, we do have to make sure that we finish the question. Our conclusion, I'm going to squeeze it here on the bottom, therefore the point of intersection is, and then just be careful that we're reading the ordered pair in the right order. X is 1 and Y is 4. I'm not going to do a formal check, but if I informally check this here, does this work? So if X is 1 and Y is 4, 4 times 1 plus 2 times 4, that'd be 8, and 4 gives us 12. That works. Here, 2 times 1 minus 4, that'd be 2 minus 4 is negative 2. So I see that that point works in both of our lines. So this is one of those scenarios you should be able to tell if you have the right answer before you submit your work, if you do that quick check, either formally, like I did here in the tables, or just informally subbing it into the equations and making sure that you get that right answer. Again, if you have any questions, make sure you email me. Otherwise, try the questions that are assigned in our classroom. Have a good day, everyone.